3.
Hey guys, we're back. We have our plates drying, and in the meantime what we're going to do is we're going to set up our phage cereal dilutions. So I've gotten out a few PCR strips right here. They hold about 200 microliters, which is perfect for what we want to do. So these are all amp plates. So what I have is a little bit of LB amp, and we're going to be doing our cereal dilutions inside of our LB amp. LBA stands for LB amp. So we're going to be doing orders of magnitude for our cereal dilution. So that means we're going to be starting off with 90 microliters volume inside of each one of these. And then we're going to be adding 10 microliters, mixing it, pipetting 10 microliters, etc. And every time you do that, it is a 10-fold dilution. Now, before we do this, let me just double check and make sure that that is going to be enough. So we have 5 times, let's see, 90. Let's go give us 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, good. So what I was just doing, I was making sure that if we make 90 microliters here, that we'll have enough to spot there. So 90 microliters, we're going to be spotting 5, so 90 divided by 5 is 18, if I remember how to do my math correctly. Is that right? Yeah, 18.
Yeah.
It's the small things. And we have 16 plates, so 18 is bigger than 16, so we're good. Alright, we got our pipette, 90 microliters. Gonna open up our LB amp, and if my flame wasn't being used right now, I'd probably flame everything off out of good habit, but I know everything's sterile because I have really good sterile technique. So 90, and I'm actually gonna, depending on how you do your cereal dilution, some people do not put LB in their first one and they just do straight up phage or cells or whatever. But I want to see, I know that there's a lot of phage in there, so I'm just going to get one more lower dilution down here. So the other trick that I'm going to do is I have 90, so I'm going to actually go down beyond the first stop, a little bit beyond, and pull up more than 90. And then I'm going to aliquot, I'm only going to be pressing to the first stop. I'm not going to eject the rest of that, so I should be putting in 90 each time. So I go back in and I still have that residual little bit of volume there. And that makes it a lot easier by pet because you don't have to deal with bubbles. It's just a little bit more consistent. So let's try to zip through these real quick. And the reason why we have 4 is because we're going to be testing 4 different phage. We have regular lambda, and we have 2 preps of that. I'm a little bit worried that one of our preps has contamination. So that's why I'm going to be testing it side by side with another prep that I have more confidence in. And then we have a lambda-vir. Lambda-vir means that the phage genome has been modified so that it cannot do lysogeny on its own. It can only do lysis. And in this particular vir strain, we have the C1 knocked out. However, if you recall from the previous video, our E. coli cells have C1. So our E. coli will be determining whether or not these cells go into lysogeny or the lysis life cycle, not the phage. So if you just took the phage and put it on normal cells, they would always go lytic no matter what, unless somehow one of those cells had C1, like our cells do. So that's the third one, and then the fourth one is that T4, and we're doing that cereal dilution on T4 so that we can take a look at our M gene to see whether that mediates protection or not. Okay, so we've aliquoted 90 microliters of LB into all of our Petri strips. Now I'm going to just kind of gently tap it down. I have a few drops that are sticking to the side of my walls, and I want to get all that liquid down into the bottom. Just gently tap it for a little while. It looks like it's all down there. Okay. Now, what I'm going to do is I'm going to be putting 10 microliters into 90 of our phage. So 10 microliters phage into 90 of LB, and that will be a 1-fold dilution. Then I'll take 10 microliters of that, put it into the next one, another 10-fold dilution, and so on. So here is our lambda-vir. I'm actually going to start with, I've done it all out here in order. So we're going to start out with our lambda number 1, 10 microliters. Whenever you're pulling off lysate, you need to be very careful. They pull off the top because we have a little bit of chloroform that just sits at the bottom there. That's just part of the prep process. So 10, so that should be 100 final volume. Then we have our lambda number 2 here. That's going to go into that second one. Then we have our lambda. Whenever you're working with phages, you want to be very careful because it's easy to create phage contamination all over your lab. If you ever do that, you work in a microbial biology lab, everybody will hate you for the rest of your life. It's awful to have phage contamination, and it can be really hard to track down if you contaminate the wrong thing. Phage can be very difficult to kill. Oftentimes bleach is the best or only, sometimes only way to kill them. And here's our T4, it's on the far right. So now we have 1 for dilutions. Now normally I'd go through with my pipette and do serial dilutions on each one of them individually, but I'm feeling lazy, so we're going to use the multi-channel. So I've taken our multi-channel, I've set it to 10, and to pick up 4 tips. And I'm going to go into our 10-fold dilution. Pipette up, down a few times. I'm looking very closely at the tips to make sure that it's going to the 10 microliter mark. The 10 microliter, or I'm sorry, the P20 tips have a little 10 microliter mark. So I've mixed it a few times. I'm going to pull up, I'm going to go into the next one down. Up and down a couple times. Up, next one down. I'm going to go up and down. I'm going to eject completely. I'm going to get rid of those tips. I'm just going to put my mark there, my finger there to mark where I was. And I'm going to get some fresh tips. And you want to switch tips every few dilutions, because sometimes you can get a drop from a very high dilution that doesn't get touched by the liquid, and then you can go down to a few orders of magnitude, and that drop will maybe finally mix in, and that will throw everything off because that drop is like 10,000 times more concentrated than any of the other ones. Okay, so you just gotta want to switch tips every now and again. I've learned that lesson the hard way. So we're gonna go in, I've already mixed, pull up 10 microliters, I'm checking my pipette tips, go down to the next level, up and down, 10 microliters, next level, I'm gonna mix it, I'm gonna get rid of it, we're pushing it all out. We've got tips, fresh tips. Again, I'm marking this with my finger, so if one of my friends comes and starts talking to me, I'm not going to lose my spot. I've also made that mistake. So always come up with little systems in your head so you can remember what you're doing if an earthquake happens. We're in California. Okay, so I'm pulling up 10 microliters, going down. Oops, got some bubbles in that one, so I'm going to eject completely, pull out. Take another 10 microliters. Next level down. And I'm actually just going to get fresh tips one last time. That last little dilution. And microliters. Mix it up real well. And then you're good to go. And then from here, what we're going to do is we're going to spot. So what I'm going to do is I'm going to rearrange all these plates in the order that I want. I'm going to remember what order these are. So we have lambda 1, lambda 2, lambda vir, T4. And then what I'm going to do is I'm going to be changing my pipette, my multi-channel pipette volume. We'll go over that in the next video, but I'm going to change it a little bit so that I can spot it. But really quickly, all that we've done here is a standard serial dilution on phage. So we put 90 microliters into all of our PCR strips, and then we put 10 microliters into that top, and then did 10 microliter serial dilutions all the way down. So that means if we had 1,000,000 at the top, then the next one we had 100,000, the next one then we have 10,000, 1,000, 100, 10, and so on and so forth. So thanks for watching. We'll be back in a few seconds.